Centerline alignment geometry. This course builds upon the skills taught in the Quick Start for Roadway Designers using OpenRoads technology course. Centerline geometry can be created using OpenRoads geometry tools. It can be imported from MicroStation Graphics, or it can be imported from inRoads, Geopack, or MX Road native formats. We will discuss all these methods in this class, but we will begin with importing from the native inRoads, Geopack, and MX Road formats. The Import Geometry tool is used to import from the native inRoads, Geopack, and MX formats. Import formats are restricted to the active software product. For example, if inRoads or Power inRoads is active, the ALG is the only format that can be imported. Geopack must be active to import the GPK format, and MX active to import the FIL format. After selecting the geometry file to import, specific geometry to import is identified via a dialog box. The options are different for each format. When importing from Geopack GPK format, you should be careful to select the correct profile to associate with each horizontal alignment, because the GPK file does not store the relationship between profiles and chains. We must identify the relationship during the import process. Notice in the image that only the mountain highway profile is selected for the mountain highway horizontal alignment, or horizontal geometry. Likewise, only the Pike Road profile is selected for the Pike Road horizontal geometry. If both profiles were selected for a horizontal geometry, both profiles would be for that horizontal. Sometimes this might be the valid and the desired result. When importing from MX, only the G string is imported since this holds the true horizontal and vertical geometric representations. In most situations, civil rules should be created when importing geometry. The civil rules establish basic element relationships and provide the ability to edit geometry using manipulators. Some complex geometry cannot be imported with the rules enabled. In these situations, a message like alignment/profile is too complex for civil rule creation will appear in the message center. However, these geometry elements are still good in that they can be used to create corridors and other civil objects. When an OpenRoads element is selected, text manipulators and handlers appear. These manipulators and handlers are used to modify the element. The text manipulator and handlers are context-aware and depend on how the geometry is created. OpenRoads technology captures your design intent when you create the geometry. The manipulators and handlers presented are based on that design intent. We will discuss design intent in more detail later in this course. For now, just understand that all geometry is not the same. How you create it makes a difference. Linear feature definitions define how geometry, horizontal and vertical, appears, including symbology such as level, color, and weight. This definition includes not just a single set of symbology, but different display parameters for how a geometry element appears in plan, profile, intersecting a profile, projected onto a profile, and on cross-sections. In addition to defining how geometry elements appear, feature definitions define how geometry elements behave when incorporated into a surface, such as break lines, voids, and boundaries. They also define how they interact with native geometry databases, ALG, GPK, and FIL. And lastly, they're also linked to native style files like the XIN, the DDB, or the PSS. We will learn more about integration with the native software later in this course. The feature definition toggle bar is used to set the active feature when creating new geometry elements. Select the feature name from the pick list and enable the Use Active Feature toggle. When you use the active feature toggle is disabled, new geometry elements are created without a feature and use the active MicroStation symbology. We use the Set Feature Definition tool to assign or change features on existing geometry elements. Vertical geometry is associated with horizontal geometry. A profile, or vertical geometry, cannot exist without horizontal geometry. However, you can have multiple vertical profiles associated with a single horizontal geometry. Vertical geometry automatically inherits the same feature definition as the horizontal geometry. To view the profile window for a horizontal element, select the element and then use the Open Profile Model tool from the Heads-Up context menu. When prompted, select the view where the profile will display. You can open a view window before selecting the view without interrupting this command. XML-based reports are available for horizontal and vertical geometry. Select the element and select the respective report tool from the Heads-Up context menu. The report tools all include a paperclip icon. The report window opens, displaying a default report format for that selected geometry, and display common horizontal geometry information such as coordinates, stationing, and curve data. Different report formats can present the data in significantly different and useful ways. For example, the horizontal alignment check integrity.xsl report will let you easily detect gaps or breaks in tangency along the alignment. The precision and format of most numbers presented in a report can easily be modified using Tools, Format Options from the menu bar drop-down. From this dialog, you can set the number of decimal places for different types of values, angle and slope formats, station formats, and more. For advanced report customization can also be completed with a bit of XML knowledge. The Bentley Civil report formats are defined using standard XML style sheets, making them easy to customize to meet your specific reporting needs. Customizing reports is outside the scope of this class. If you want to change the default report that appears when a report tool is run, select the desired report from the left side of the window, right-click on that report, and select Set as Default Geometry, or one of the other Set As options corresponding to the type of report that you're working on. Reports can be printed directly from Bentley Civil Report Browser window by selecting File Print. Reports also can be put into spreadsheets by right-clicking on the report in the right frame of the browser window and selecting Export to Microsoft Excel, or by going to File, Save As, and saving it into an Excel or Word document.